Woo, Tana! Okay, so here's how you do it. You graph your function as such, and then for A, when it says domain and range in interval notation. Okay, so you can see here that this is increasing, this is decreasing, and then you can see that this is moving to the right slowly, but it still is, and this is moving to the left. So both your domain and range are all real numbers. So in interval notation, that's going to be that the domain is the interval negative infinity to infinity, and the range is the interval negative infinity to infinity, using parentheses because infinity is not a number, so it cannot be included in the solution set. Okay, and then the increasing intervals, looking at your function itself, to tell if it's increasing, we have to look at what the y values are doing, since the y equals f of x, so y is equal to the simplified function. So for any value of x. So when we see here our y values are increasing, so where do they stop increasing? Right there. So what we can do is we can go second, sorry it's weird to see my finger through the video, second calc, and we're going to look for the increasing interval by seeing where it stops. So we're going to look for 4. Okay, so we're looking for the maximum. So we want our left bound to be 1, 2 at x equals negative 2. We want our right bound to be right here at 0. And I wanted to guess. Boom. So in the interval from negative infinity to, let's see, what was that? That y value? So negative 0.7453 is where the y values start to decrease. So negative 0.745, and then let's say 4 because it was 536 after that. Okay, so that is the increasing interval number 1, and the increasing interval number 2, we're going to go second calc, we're going to look for the minimum, so 3, in between 0 and, let's see here, 1, 2. 2. And so the minimum is at 0.7453562, so it's exactly the same, just negative. So, and then here we have 0.7454 to infinity. Those are our increasing intervals because that's where the y's are increasing. You can see like here and then here. From here to here is where it decreases. We already know those x values there. So when it says decreasing interval, we can say from, you know what? Let's actually change these to parentheses because at an exact point it's not doing either. Okay, so parentheses from negative 754 to positive 0.7454. That's where it's decreasing. And that's the only interval where it decreases because it continues forever that way and it continues forever that way. And then the relative minimum is going to be this point right here because that is, it's not the lowest point the graph reaches. The lowest point the graph reaches is negative infinity. But here at this exact value of this point, that's the relative minimum. So this is the minimum because when we refer to the function as a whole, we're talking about the y values. So the relative minimum is going to be negative 2.48452, and the relative maximum is right here. So we have to go back because I didn't keep track of it. So second calc, and then we're going to go maximum, and our left bound is negative 2, our right bound is 0, and guess. So at positive 2.48452. Now that's not the absolute maximum because the maximum is undefined because it's infinity. It increases forever. So our relative maximum is going to be here, 2.48452. 2.48452. It's a thumbs up. Okay.